All right, and for this one, let's just look at YouTube really quickly, and I'm just going to go out to this, and we should see with a refresh the new link, which is this one. And I'm going to put that one on Teams. And this insanity, and I say insanity as in like, I'm doing this. But it's fun. It's all fun, man. And we're also going to put it up on Discord. I know you guys are laughing at me like, he's crazy. He's crazy. Right? And I'm also going to put it up on, I'm going to fix, if it doesn't say something that's right, like if it says something that's is not coded properly, like I'm coding it here, I'll go back later on YouTube and make it all nice. Don't worry, okay? That's why I use YouTube too, because I can fix things. As well as my lovely content here. Again, one thing that you're going to notice is that that all of this content is unlisted, okay? So you don't have to worry. Okay, welcome back. We are MDEV1001, that's Mobile Data Management in the summer 2023 semester at Georgian, and it's week 1, part 2 of our broadcast and recording, as we're recording on YouTube, on Teams, on everything else, plus we're live, and we're synchronous and asynchronous, right? Lots of stuff going on. And where last we left off, we talked about the schedule, and we were looking at the agenda for today, and really what we've done is we've knocked off this one. What is the course about? What is the course about? And so for this part, we're going to talk about databases a little bit, and this is probably going to be the driest part, the part that I don't like, the part that I got to talk about, but the part that's got some slides, right? One thing I'm going to talk about is when I talk about the slides and I say like, what is a database and all this kind of stuff, I'm going to talk to the slide. I may not read everything in the slide. The slides are replacing your book, right? So there is no book for this course. I'm not recommending a book because the course is made by me, right? So I'm the book, right? So I'm giving you the slides, and anything that's on the slides is fair game. If I get you to study, the quiz will not be made from any book. It's going to be made from my slides, okay? So let's talk about databases. And databases, anyone know what a database is other than what it says here? Database, what is a database? Come on, easy.
Used to save data.
Save data. What else? What else do we do with the database? Forget what the slide says. Talk to me, yeah.
Database is like a storage device where we can store data and use it.
Okay. Storage device, yeah, that I'm hearing, that you can use it whenever you want, right? Okay.
Also make changes to it.
Make changes, yeah, you make changes, that's good. You can organize it, sure. We can do that. We have a lot of storage devices, right? We have our hard drives. Is that a database? But I mean, I can store data and I can manipulate it and everything else. What's the difference between a hard drive and a database? Hard drive, direct access. Database, is it direct access?
Database saves the data according, let's say, there's a primary key, there's field which is unique, right?
Okay.
You can call data, right? You can extract data from which ID we want to extract data.
Okay.
We can,
So what I'm hearing is you have an index, you have some kind of unique ID, typically that represents the data.
yeah.
When we think about a database, when we think about it, it's like it's like a table in some ways. We look at tables first. The first table, who uses Excel? Anybody use Excel? Anybody? How about people not using Excel? Do you guys use Excel? Kind of? Yes? Excel is like, there's fields and stuff. Is Excel a database? I mean, it kind of qualifies. I could put in a unique ID in there. Is it a database? Excel, right? I mean, it's a tool, right? It's a tool. How about this? Is Access a database? Microsoft Access. Microsoft Access is a database. It's considered a database, but actually, Microsoft Access is a database system, right? So there's a difference between the database itself and the database system. The database system is like the tools, the software, the server that hosts your database. That's the database system. Could be Access, local system, right? It could be SQLite, local system, right? It could be remote, MongoDB, or it could be somewhere on AWS or GCP, Google Cloud Platform. Could be there, right? Could be on Microsoft Azure. That's the platform. That's the database management system, right? But the database is a collection of tables, not what it says here, a collection of tables, that basically provide us some data, and they also provide us context. The database tells a story, seriously, right? When you look at the database, it's not just data that it looks at, but it actually tells a story. It says, okay, what kind of data am I looking at here? I'm looking at data of people. Let's say my database has the person table, and the person table has the first name, last name, telephone number, some kind of email address, maybe an image, right? Each row in that database, right? Each row is a record. That's what we say, it's a record. Each record is data about that person. But it tells a story. Hopefully people can hear me from the mic. You can't see me anymore because I'm going to walk away, all right? But it tells a story, right? That's what the data is. And we're full of data. Data is everywhere in our world, right? We continually make data a lot, all the time. How many emails do you guys send off a day, every day? Emails. One? Emails used to be, like back in the day, was the killer app for phones, right? It was the real reason why we had these things in the first place. We had phones because I wanted to send email to people, right? We never had texting. Texting was we had function phones, right? We didn't have like a computer, which is what this is. It's a computer in my pocket, right? What we had was things we can press buttons. Our phones were closer to calculators back when I first started, right? That's what they were. And the calculators all have each number has some letters, remember? And you can type those letters to have a text. It was terrible. No one did it, right? Until they started doing it. And then they realized we need a full keyboard, right? How many people use texting nowadays? Not Discord, not thing. How many texts do you send a day? Texts. 10? Would you say 10? Would you say more than 10? How about lines of text? Lines of text. So not just text, not just a text, communication to person. Each line of text that you send, do you just send one big wall of text to somebody? Right? No. Where is that data being stored? In a database. 100%, guys. It's being stored in a database somewhere. That means your data is not secure, no matter what people tell you, right? It's being stored somewhere on the server. Most likely here in Canada, or in Toronto, and in the Toronto area, Barrie, right? Either Rogers or Bell. Those are the two main things. And if you don't get Rogers or Bell and you get some other provider, it goes through Rogers and Bell anyway, okay? That's where it's being stored, somewhere there. And then it goes through there, that's the journey, and it goes somewhere on Apple servers, somewhere else on the email server that you're using, right? Or text, or something like that. Your data is being stored somewhere. So data is not secure. And some people have this problem. It's not a security course, but it could be. It could be a security course, no problem with what I'm talking about, right? Because people are very comfortable sharing their data without even thinking about it all the time, right? You don't really think what you're doing. Do you think that when you're searching the net here in school, it's secure? That IT is not watching you? They're watching you. They're checking to see if you're going to a bad site. They're not going to let you go to every site here at school. Okay? Reality, right? So your data is not secure, and a lot of times it's being stored somewhere on a database. But there's different types of data. Data, that's why this whole idea of big data. Data tells a picture, right? If we actually look at all your patterns, the sites you go on, the games that you play, right? The games that you play, whether it's on the phone. Who plays phones on the games on the phone? Who does that? Like, you guys play phone games? Yes? What kind of games on the phone do you play? Candy Crush. That's a huge game, right? It's great. How about the guys over there? Ever play on the phone at all? What's that? On the phone? You play multiplayer games on the phone? I couldn't do that, man. That's crazy, right? Huh? Chess. Okay. Chess. Okay. How about Sudoku? Who plays Sudoku on the phone? Or Word with Friends, or Wordle. How about Wordle? That's a big one now, right? Wordle is a big one. That people do that. You got to do Wordle, or else bad things will happen to your brain. You got to do that Wordle game every day. That data is going somewhere. That's the point. Call of Duty on the phone? Come on. Vivek is saying Call of Duty on the phone. In fact, I don't believe you. Call of Duty on the phone. It's crazy, right? It's like playing like, some other thing. Minecraft on the phone. People play Minecraft on the phone too. The point is your data is going somewhere and it tells a story. And databases tell a story too, even though databases are primitive by your understanding, right? I'm actually slowing you guys down when I say database. When I say data means a whole different thing than database. Database is where I'm storing something and it's usually got some kind of structure. Okay, databases are orderly in many ways, right? Okay. So let's continue. So again, we have 3 key points about databases. And if I was going to ask you to do a quiz like next week, hint, hint, when we come in, and I ask you a question about databases, right? And if I said there's 3 key points about databases, right? They store data, there's some organization, and we do some kind of management, right? And a lot of times we do something called CRUD. It's an ugly word, right? CRUD. Create, read, update, and delete. It's going to be one of these things we're going to be talking about all the time. CRUD. I want you guys to do full CRUD. Full create, read, update, and delete. Full data management is what we're talking about here, right? So that's what we do, those 3 points. And how about benefits? Data integrity. This is really good. One thing that's different about the data that we use from day to day, like texting, Discord, game data, right? Data that you play with Candy Crush, right? All that kind of stuff. The difference between that and a database is that databases check to see if the data that you're putting into them is the right data most of the time, right? Like if you try and enter a postal code in a zip code, you're trying to order something from the United States. I don't know if you ever try and do that. Anybody? And it's asking you for a zip code. And you're like, zip code? What's that? We're in Canada, right? And you can't put a zip code in because you're in a postal code. It won't allow you to put letters and numbers because there's validation. Validation happens in 3 places, right, in an application. What are the 3 places it happens? Think about it. 3 places it happens if it's a good application. Tell me one of the places that validation happens, which means I validate that the data is correct. Where does it happen? Tell me one.
Front-end, back-end, and database.
Okay. Database, back-end, someone said. There's 3 places. So your first part is your UI. Your UI should do some front end, like he said. Who spoke, by the way? I didn't see who the person was that spoke. It was too quick for me, right?
It was me. Sorry.
I don't know. Name. Maybe you want to put it in the chat. Because I want to talk about you a little bit because you said something that's nice, which is client-side. Client-side data validation, which means that, thank you, Arno. So client-side data validation means I have a website, I have a phone, and on the phone or the website, the front end, your form that you're entering stuff in, there's data validation there. It's going to check to see that you're putting in the right stuff. That's the first place. The second place is the back end, which is your server, right? And your server is also going to check to see, is the stuff that I'm getting from the front end the right stuff? Because if I'm a malicious user, if I'm a bad actor, if I'm a hacker, maybe I can circumvent the data that's supposed to go on the front end, right? And send some weird data to the back end. The back end should also check. That's number 2, right? That's your second line of defense. The back end says the data is good. Then it goes to the database. And the database checks again to see that the data type and what you're entering in makes sense. So that's the 3 lines of defense. We still have some bad data that goes on the databases. We see it all the time, right? Why? Because nothing can stop a human from making lots of mistakes. That's why. Humans are the worst part of the security, kind of loop, if you think about it. If we didn't have humans, there'd be no problem with security, right? But then we wouldn't need security because we wouldn't have humans, right? And it's kind of the same thing when we talk about customers. If we just didn't have those customers, then our lives would be easier. Well, if you didn't have customers, then you wouldn't really be doing this job, so then it's kind of weird, right? Customers are the people that always try and, or always mess you up. All right. So what is a relational database then? So we talked about what's a database. What's the difference between a database and what do we say relational? What does that mean? Relational database. Well, I got a picture here that kind of talks to it. And I pulled this off the internet today, right, when I was doing it. And I said to myself, it's not a bad little picture. You have, some kind of relationship between 2 tables, right? And this relationship, again, it tells a story. I have a customer ID, which is a primary key, all data in a database table somewhere has some kind of key or ID, something like that, okay? And then that primary key, there's another primary key at another table, and the primary key in one table is called the foreign key in the other table. That's what it's going to be, right? And we have a connection. There's a connection between customers and orders. What's the connection? What's the relationship between customers and orders? Is it a one-to-one relationship? One to many. So this is something else we talk about. When we talk about relationships, we usually have a one-to-many relationship. You know, how about, I hate to say this, but how about like, I don't know, wives and husbands? Is that like a one-to-one relationship, or is that like a one-to-many relationship? You know, well, in some countries, it's a one-to-many relationship, and it's okay, right? It's okay. But in a lot of countries, other countries, it's usually a one-to-one relationship. Otherwise, you know, the wife and the husband, right? Bad things happen, right? So there's different kinds of relationship, one-to-one and one-to-many. How about another one? Here's another example, one-to-one and one-to-many. Courses and students. What kind of relationship is that? Courses and students. I can have, a student can have, oh, there we go. Many to many. There's another one, a many to many relationship. That's really complex, right? That means one student can have a lot of courses, different courses, many courses, but each course can have many students, right? Many to many. So this is the relationships we're talking about. One to many, many to many, many to many, and also one to one. Okay? Those are typically the way it goes, okay? And there's others. And there's others, okay? But I wanted to mention this because that is the core of what is a relational database. Here's the qualifying, guys, I want you to think about this, right? There's no one solution. There's no one best solution. It's not like when you're playing a game and you're like, what's the best setup? What's my best loadout when I'm playing a game? Like, there's always a best loadout for PvP or PvE. Or there's some kind of suggestion that they tell you to do something. This is the best computer you can buy, or this is the best phone you can have. There is no best solution for you. It's not one size fits all is what I'm saying, right? So don't anyone tell you that, you know, MongoDB and NoSQL and no relationships are the best solution. Or relationship, you know, like a relational database, that's the best solution. There's no best solution. You got to use the right tool for the right job. If you have relationships in your data, use a relational database. If there's no relationships and you only have one single table, you don't need a relational database, right? Okay. One thing we have to talk about is some keywords, tables and records. We have a table, which is kind of like a list of records. Each record has different columns. A lot of times, each column is unique and has and defines different attributes. For example, if I had a person class, right? A person object. The person object most likely is going to have a name, some kind of maybe an age, right? Maybe a first name and last name, maybe an occupation, maybe they're a student or they're a teacher, maybe an email address, maybe a physical address, maybe a physical address here and a physical address back home, right? Lots of stuff, right? And all of those things are unique, okay? But they're all the same. If I look at one record, it should be set up the exact same way as the next record for the table. They're all contiguous, and the data is the same for the entire column. Okay, that is a relational database, right? There's also something called a primary key. And a primary key is something that is unique. It identifies each of the records. So every record in the table has got a unique ID. I know this is like, guys, if you guys are like done databases before, you're like, oh my God, this is like, you know, grade school computers right now he's talking about. But again, you know what? I don't know where you guys come from. I don't know what your background is. Maybe you've never done databases before. So that's why I'm covering it now. Okay? So primary key, foreign key, we talked about. There's something else with relational database. We use a way of getting data. We use something called a structured query language, or SQL. All right? A lot of times when we're talking about databases, we're going to say SQL. Sometimes people call it SQL. Okay? Both ways are interchangeable. I might even say SQL, right? But it's really SQL, structured query language is what I call it. It didn't come from that. It came from something else before, all right? SQL is actually a trademark name, okay? It belongs to a company, but we always use it anyway, right? Structured query language, SQL. And what we do is we give a command. It's a command, right? There's two ways of doing structured query language. One way is a sequence of words that mean something, right? For example, insert into table, and here are the values, right? That's what I'm saying, insert. Or delete from this, as an example. Or select this many records from this table, and match this pattern, right? So that's what we kind of say. It's almost like a wordy way of talking about, and we're going to learn some amount. It's not all about SQL this semester, but we're going to learn some SQL, right, when we're talking about stuff. So you should be familiar with it. I don't expect you to be masters at it, all right? I don't expect you to be experts. If you don't remember, there's always ChatGPT, right? There's always Stack Overflow. There's always some other Google tool that you're going to use, right? It's okay. As long as you can make it do what I want you to do, I'm fine with it, because the customer would be fine too. Why would they care? They don't know what you did, right? And neither do I. The next part is we use SQL to retrieve, update, and we say manage, but it's also, we do this full CRUD stuff with SQL, all right? And this, by the way, only pertains to relational data, right? SQL or SQL, it only is used for relational databases. We'll come back to the other type in a second. And then we have data consistency and normalization. Normalization is a weird word. It means different things in different contexts. If I'm talking about game development, normalization means a completely different thing, right? A good example of this is vectors. Anyone remember vectors way back in the day? You guys did vectors in school? What is a vector? This is completely off topic, but I love games, so I got to talk about it. What is a vector? Huh?
Goes only in one direction.
Direction. It's a coordinate, X and Y. Math. I know math is terrible, right? Math. It has some kind of magnitude and direction, right? Vector. When I say I want to get a normalized vector, or I want to create the unit vector, I take the magnitude and divide it over its components, and I get that number that adds up to 1, from 0 to 1. I normalize something, I make it from 0 to 1. In math, in probability, in statistics, right? In machine learning, we normalize a whole bunch all the time. We take a bunch of numbers. A good example is the color spectrum, right? I have 3 color channels, typically what I use, and a fourth one for transparency, right? So I have got red, green, and blue, and I have alpha transparency, right? I can make them from 0 to 255, or I can also go from 0 to 1. How do I go from 0 to 1? I divide the number over 255, and I get the number from 0 to 1, where 0 is 0% and 1 is 100%. Normalization, right? That's what it means in different contexts. Here, we're not talking about normalization like that. Here, we're talking about removing redundancy. I want to look at my table and remove duplicate data. That's normalization, right? Why? Because if I have a lot of duplicate data, I got garbage coming back out. You know what they say? Garbage in, garbage out, right? We don't want to have garbage in our table, so we want to go through a normalization step and reduce redundancy, right? And when we reduce redundancy, it's good, but it also can be bad. And there's positives and negatives around it. So that's data consistency and normalization. Consistency comes from our data types. It forces us through validation to have the same data in every column. That's what it does, okay? What about data integrity and constraints? We talked about this as we have a primary key. We also have some constraints in terms of how we put the data in, and we want to make sure that the accuracy is there when we from the front end to the back end to the database itself, okay? Now, there's a lot of different kinds of relational databases, and I put them in this one slide for you, which is not really great practice if I was presenting. If I'm going to be a presenter, by the way, if I ever get you guys to do presentations for me in any other course, 3 points max on a slide, ever. Okay? Walls of text are ugly. No one reads that stuff anyway. Okay? Three bullet points max. Okay, guys? Here, this is not a presentation slide. This is a teaching slide, so I have lots of stuff in here. Maybe I'm giving myself an excuse, but it's true. It's what it is, right? So there's a bunch of different popular databases. MySQL, see, I just said it, MySQL. MySQL, which is an open source version of a SQL database. Very popular database for web services, right? PHP, MySQL, right? PHP and MySQL is a very common solution stack. HTML, JavaScript, PHP, MySQL. PHP is 70% of the internet still, all right? Which is crazy because it's old, okay? MySQL is a database that's used for WordPress. Everyone uses WordPress with MySQL, okay? Oracle database, one of the most feature-rich professional databases out there right now, right? Oracle also owns Java, right? At one point in time, Java was open source, not anymore. Oracle owns Java, and that's why Google has gone and made Kotlin. Kotlin has been created to make Android applications because Java is owned by Oracle, okay? Microsoft, and again, an awesome SQL server, one of the first ones. Oracle really owns the SQL name. That's where it comes from. But Microsoft's SQL Server is Microsoft's version of the same DBMS, Database Management System, okay? DBMS. PostgreSQL, weird way of saying it, is an amazing system, which is an alternative to MySQL, all right? Again, it's open source, it's really advanced, and it's much more secure in many ways than MySQL, all right? So very popular back end. PHP, Postgres, HTML, JavaScript. That's a solution stack for a web service, okay? IBM DB2, one of the oldest ones here. A very, very old database system, but still in use today, especially in enterprise, okay? And finally, SQLite, which is used by all of your devices that you have in your pocket, and the internet too, right? We're going to be focusing on SQLite in this course more than anything else for local data. Why? Because the other courses you're doing, Android and iOS, they're going to use other solutions, core data for iOS. You're going to see other solutions. We're going to be talking about different types of local data that we're going to be discussing next week. Okay, but SQLite is the thing that we're going to be focusing on. I want you guys to do a little bit of SQLite today. Yeah, that's why you're going to need your computer, right? All right, let's continue. So that's different types. So what about the benefit? Why do we want structured data models? Because it requires a lot of stuff, right? You have to have a solid model class, all right? Again, going back to object-oriented programming, what are classes? You're asking me for basics. This is a basic question. What are classes? What's a class? In object-oriented programming, C#, C++, Java, Python.
A way to define and bind objects, data, and methods together.
You're a good man, right? Yes, it is. It's a blueprint. It's like if I want to define what a person is, I can create a class. And the class itself defines, in many ways, the attributes and the functions related to that person, what that person can do. The person class, an example, might be able to do things like, I don't know, eat. People can eat, people can talk, right? People can do things, right? Their actions, the operations that they can perform, right, are functions, right? And the attributes, their hair color, their height, how fit or not they are, all those kind of things. They're all attributes. And we define that in a class, right? The class itself defines the data for our model. So we have something called a data class or some kind of model class. It's just a class. That's what it is. And whenever we connect it to a relational database, it has to be very, very, very well structured. There's advantages and disadvantages to this. Advantage, it's well structured. Disadvantage, it's very rigid, right? So you have to do things in a certain way. It's almost like you have to go with the beat of a drum. You cannot do it in any other way. You must have this kind of data. It must have these things. If you're missing one piece of data, it will not work. You cannot have different types of data in one column. It has to be the same type of data the entire way, okay? Very structured. Good advantage of this is really efficient querying. You're going to get the same data back every single time. Really, really efficient about that, okay? And like it says, some standardization. Different kinds of relationships. I can make relationships and joins. When I want to join two pieces of data together, two tables, and I want to create a virtual table when I kind of have two data sets. I have a data set over here, table, second data set, and I want to kind of join them together. This overlap of things that I want to join them together is the resulting data set, the join, right? Then it makes sense because it's very structured. Yay, right? It's good. And there's some consistency and normalization and other things that we talk about here as well. What about non-relational databases, and why the heck do they exist? Why do we have non-relational databases? Because we need flexibility. Because not all data, remember, we said this before. It's not one size fits all. It's not one tool that's magic, that's going to solve everyone's problems. We need different things to solve different problems. Back in 2007, let's talk about some history, all right, that I want to talk about. There was a revolution in web design, web sites. And it happened with the Chrome browser, the V8 engine that came back in 2007. I remember this. JavaScript was changing at the time. And people were complaining about all those things I talked about just now. I need to learn, if I want to do web development, which is one of the hardest things you can learn, and I would stack them like this. Hard things to do in software engineering. Number one, game development. Number one, hardest thing you can do, right? And you're going to be like, Tom, I disagree with you. Trust me. Hardest thing to do, game development, number one. Next, underneath that, mobile development, what you guys are doing. Second hardest thing to do, okay? Then one step lower, web development. Third hardest thing to do, right? And then underneath that, regular software development, right, is the fourth hardest thing to do. And you're going to be like, no, I disagree. AI should be in there too. Yeah, that's under software engineering, okay? It's not as hard as the other ones. There's a structure to it all. Why am I saying that? Because game development, it's a multidisciplinary art. You have art, design, and engineering. You have graphics and AI and everything in one place to make a game. And by the way, it has to be fun somehow, right? Which is magic, right? That's why making a good game is really hard. Redfall just came out, worst game ever, right? 4 stars, or 4 out of 10, I mean. So it means that's 2 stars, right? Yeah, maybe even 1 star, right? And they keep on coming up with these games that they try and make them, they're hundreds of millions of dollars, more money than a movie, and they're not fun, and they're not good, right? And the companies that are making them are losing money, you might think, but they're actually not. Second thing is mobile development. Why is it hard? Because mobile development, you need to know the devices. Android, how many hundreds of devices did Android have? Hundreds. I bet you half of you guys don't even have the same phone, right? Which means hardware differences between one application and the other. And I don't know if my application is going to work on everyone's hardware. I have no idea. Apple's solution to that is everyone has an iPhone, right? And they're all contiguous. They're all the same. And they want to get you going on the same level, and they deprecate all the other ones. You know, for example, the iPhone 6 can't run the latest version of iOS. Why? Because they want you to buy the new iPhone, right? So they're smart. They have a different perspective on things. So if you think about that, then it goes to web. Web changes constantly, okay? So JavaScript, 2007. We're having problems with JavaScript. It was hard to use to do Java. Who knows JavaScript really well? Really well. Who's an expert? Who's a ninja in JavaScript? I'm going to leave my hand up because I am really good at JavaScript, okay? But that didn't happen overnight. That happened over years of failure, right? Years of trouble using JavaScript, right? And in 2007, people were getting fed up. They had HTML, JavaScript, PHP, SQL, right? And that was just to make a basic website. I need to know all of those languages, plus I need to know hardware, plus I need to know networking, front end, back end, servers, web browsers, kinds of crazy stuff, right? Databases. People were fed up. And they said, listen, what if we could do JavaScript everywhere? Right? JavaScript is a pretty good language, pretty, flexible language. What if we could do JavaScript on the front end, JavaScript on the back end, and JavaScript on a database? Wouldn't that be awesome? Forget SQL. If I only knew one language, that cuts down 3 languages I need to know. And that means JavaScript becomes the most important language in the world, if you think about it, which in many ways it is today. JavaScript, the most important language in the world. If you talk to the person who made JavaScript, he's going to say, it never was meant for that. I never meant JavaScript to be this way. It was supposed to be something we did over the weekend. We put it together. And JavaScript is based on something else called ECMAScript, right? The latest version of ECMAScript is M2023. Every year in July, they come up with another version, right? That's what they kind of do, 2022, 2023, right? And they upgrade the standards, which means JavaScript continues to change. This is why web is so difficult, right? HTML5 continues to change, right? CSS3 continues to change and evolve, right? So those are all things that are changing. PHP has changed to some degree, but the popularity of PHP has gone down because PHP is a multi-threaded environment that actually is less performant when you have thousands of users accessing a website compared to Node.js, which is now becoming the most popular backend or some variant of Node.js. Example, Next.js, and so on. All right, so Node.js. So back in 2007, they were like, hey, we need one language, JavaScript, to rule them all, right? Like one ring to rule them all, right? One language to rule them all. We want to cut down on the noise because when you go to the interview, they're like, do you know JavaScript? Do you know HTML? Do you know PHP, CSS, SQL? Do you know about, there's a lot to know, right? And they're like, that's only if you're a junior, by the way. Never mind version control and back-end stuff. So that's where it came from. It came from like, hey, we need flexibility. And so we have these non-relational databases because sometimes a website only needs one table. It doesn't need relationships, right? Sometimes a phone only needs one set of data. It doesn't need relationships with multiple types of data, right? And so why am I going to have this massive thing that I need to know SQL? I don't need to know SQL language at all when I just need to know JavaScript, okay? Or something like it, JSON, JavaScript object notation. If I know JavaScript object notation, JSON, then I understand how the data is formatted in today's modern web services, okay? So there's two types. There's key value, actually there's three types. Key value, document, and mostly graph. Columnar, I haven't seen very much. Key value stores, Redis and Amazon DynamoDB are examples of those two, right, of those types. Document databases, which is what we're focusing this course on, okay, is MongoDB and Firebase Firestore. Those are two document-based, document-oriented databases, not relationship databases at all. There is no SQL to access those things. We use a JSON-like syntax to access the data. So if you know JSON, I call it JSON, right? Then, JavaScript object notation, then you understand what it looks like on MongoDB or on Firebase. On MongoDB, they actually call it BSON, right? Binary object notation, right? But the form is very similar. All right, so that's like document-oriented databases. Let's talk about some fundamentals. All databases have data independence, and there's always the ACID test. This is an actual thing they talk about. Does it pass the ACID test, right? Which is atomicity, consistency, isolation, and durability, right? You guys can read about that. I'm not going to go into the details there, but it makes sense, some of the things that it talks about here. So example, transactions are treated as a single unit of work and so on. Data modeling. We talked about the data model being a class, right? Like the person class. Or what if I made another class that derives from the person class? I'm talking about now inheritance, right? I have the person class, and the person class is really general. Who is just a person? Where we have multiple roles we take in life. For example, you guys right now are students, but maybe some of you might be also tutors. So you might have multiple roles. I have a student, tutor, and I'm also a person, right? And maybe there's different kinds of students. There's the domestic student, and there's an international student. Again, another layer of hierarchy, right? So when we do data modeling, what we want to do is model the database so that it works well in life. So that the business model, the business idea, what we're trying to convey in our code is the same as the data model we're creating for our database. If somehow there's a disconnect, it's not going to make sense. And this is where the data is old, and we have a lot of what we call tech debt at the end. Database management system we talked about. Query language we talked about. It allows us to read, insert, update, and delete. We talked about this as CRUD, like we talked about before. And then we also have some other things. An entity relationship modeling, or we also kind of create something called entity relationship diagrams. We're going to do that next week. We're going to start talking about diagramming, describing tables without coding at all first. What does it look like, right? By the way, how about UML? Do you guys know UML? You said you're not hands-on. Did you guys do UML diagramming? UML, like when you actually describe classes by pictures. No? Well, we're going to do that together, right? UML diagrams. So UML diagrams describe the data class, and then your entity relationship diagram, or ERM, the model itself, it describes the relationship that it has between two tables or whatever. Where does it sit, this table? Normalization. There's also something called denormalization. Sometimes, even though we want to add redundancy to a table, we had extra the same kind of data over and over again. And the reason why we want to add redundancy is so that the read performance is faster, actually, with redundancy. That's what we found. Although your data is kind of weird. Other things to note is we have, for relational databases alone, primary keys. We don't have a primary key for a non-relational database, right? We have an ID, a document ID, for a non-relational database. We also have foreign keys, indexing. I'm going to keep going. Let's talk about non-relational databases. So databases that do not have any kind of relationships at all, right? They have something called a schema-less design. So when we talk about a model class, we're talking about a schema, some kind of plan or blueprint for what the row of the table is going to look like, right? A schema-less design is interesting because non-relational databases, because they use this JavaScript, very loosely typed kind of thing, you can put whatever thing you want in the document. Each document can be completely different too. One document can be one way and another document can be completely different. And what you lose on that way is consistency. You don't have very consistency between documents. You don't know if one person is very much different than another person. You might have the first name of one person and the first name and last name of the other person. And if you don't have both, oh well. Truly, this is the thing. But it provides us with flexibility. Flexibility when we don't need structure, like on a mobile device. Sometimes we don't need that structure, that hard structure that we get from a database, a relational database. And it talks about here about some benefits of schema flexibility. Rapid application development. I want to put my stuff together really, really quickly. I don't care if the data is exact. I want some mock data that I want to put together. Rapid application development. I can change my model. If it's working today, I thought about maybe making a person, but tomorrow I want to change to a student, I can do that. I can change my model. It's no problem. Without too much migration, right? Because it doesn't care. Each document can be different, right? Whereas, if I want to change my model on a relational database, good luck. There's a migration policy. I got to migrate from this type of table to this other type of table over here. And there's a huge migration thing that might fail. You might even destroy your database if you don't do it right, okay? So that's the good thing about the flexibility. And other things here. Big data. It's the ability for it to handle huge data is a big thing. So that is the story that I want to tell you, and I want to stop talking now. I talked another hour, right, or 45 minutes, all about databases. And you might think, I'm going to put it out there, I'll drink some water now too. You might think that, thanks so much, Tom, that really, thank you for that lecture. I'm never going to need to know that again. Let's see what happens next week. Maybe we'll do a bit of a quiz, I don't know. Hint, hint. And the quiz again will be, if I do a quiz with you guys, it'll be done with respect to the slides. If I ever do anything like that, it usually will be short and it'll be accompanied by something else. Because remember, 4%, if I give you, how many questions do I have to give you for 4%? Think about it. Is 4 questions okay? 1 question per percent? You get a question wrong and you drop a percent? Woohoo, right? Can't. So there's got to be more than 4 questions. How about 8? That's like 0.5% per question. Woohoo! That's pretty crazy. Okay, now we're talking. How about 12? How many questions do I get? It's got to be reasonable because if I make it lower questions, you're like, oh, those are 4 questions. I'm going to be perfect. But what if you miss 1? Right? Now you only got 75%. Right? It's like a cut. We don't want that to happen. That's why there's probably going to be more than 4 questions if I do a quiz with you guys ever. Okay? And they're going to be randomized and blah, 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 blah. But you guys can defeat all that. I know that. Let's take a short break. again. And then, yes, questions?
I just have a general question.
Yes.
So, like, were relational databases a solution to the problem we faced with non-relational, or was it versa?
Relational databases came first, right? When they thought about how to organize things, there was some kind of person out there that was very structured, and they liked patterns and everything else. The people were there putting things together like, we must have structure. It was like a hierarchy, right? And yes, at the time it solved a lot of problems because we had a lot of data and we wanted to make connections between one table and another, one type of data and the other. And for many years it solved problems, but then it caused other problems. Like, holy crap, what kind of overhead do I have? I have this much overhead to create a data table for my little application that's this big. One size does not fit all. That's the reason why it happened, right? They're like, wait, and I need to know this language and this language and this language, and I have to have this API to connect to the data. And it was just crazy, right? So that's what they were trying to do, to answer your question, is they tried to simplify. Now, I got to talk about this a little bit before we stop. Thank you for reminding me. Even though we say that non-relational databases can be schemaless, right? Often we use a schema. Often we structure them anyway. Why? Because we're structured people, us programmers, right? And it's hard for us to put, like, slap data together in random spots and think that it's okay. For me, it kind of, I don't know, bothers me. I can't just like look at like strings and integers and floats and everything in one like field. It just drives me crazy, right? I want some kind of structure. And then now, that's how it started. It started very flexible, and now we're back to rigidity again. That's reality, okay? But we're gonna get into that next week. So let's take a short break. We're sitting at 6:04. Let's take 5 minutes. Roughly 6:10, we'll come back, and we'll finish off the night with a small example and some setup for you guys, okay? Let's do that now. I'll stop recording. You're dying over there? I'm killing you? I don't know.